All right, let's get underway. Next generation fleet and other innovations. We're about to meet Simon Herring, the Acting Firefighting Advancement and Research New South Wales RFS officers. Inspector Simon Herring joined Loftus Rural Fire Brigade in the Shire in the Sutherland District more than 20 years ago. He's held a number of different positions over that time, including, including Deputy Captain. His first ever job, though, was he is a former personal trainer in the fitness industry. Nothing to do with what he's doing now. Continuing to be a volunteer, Simon joined the salaried ranks of the RFS working in Mitigation Crew before progressing to an operational officer. In 2022, he was appointed Supervisor Emergency Management in State Operations, and he's currently Acting Manager, Firefighting Advancement and Research, providing fire and emergency service expertise while pursuing technical firefighting advancements and industry research for the RFS. He's been awarded with the Commissioner's Citation for Service National Medal, National Emergency Medal, the RFS Long Service Medal and the Premier's Bushfire Emergency Citation. He tells me that outside of work, he loves nothing more than mountain biking, getting out and amongst it in nature, but hasn't really been able to do that in recent years because he has a young family. His time is taken up with a 2.5-year-old daughter, and literally 6 weeks ago, he had a son. So he is juggling sleep at the moment. He might be the only person at a conference to fall asleep during his own presentation. It's possible. He joins us to talk next generation fleet and other innovations. He is Huggies Nappy's #1 customer. Please welcome Inspector Simon Herring.
Well, thank you very much, and if I can just figure out the clicker. Oh, no, we're going to go back. Here we go. Okay, so as introduced, my name's Simon Herring. I'm the Acting Manager, Firefighting Advancement and Research with the Rural Fire Service. We're a relatively new team that's been established in the RFS since around the 1925 season, but I just want to talk a little bit about the establishment of our team, but also acknowledging a lot of the innovation that's occurred in the RFS over the last 120 years. The innovation in the RFS is not something new. It's not something that we've just taken on in the last 5 or so years. I walk around out the front and look at the heritage trucks. I walk around out the back and have a look at some of the new technology. That's the innovation of the RFS over the last 120 years that has got us to a point where we are today. Moving forward, and I'm about to talk about a number of projects that we are working on as part of the innovation team. We are trying to get the RFS Future Fit ready for what does firefighting, what does emergency services look like for the next 20 years. Some of the key focus areas for the team that I'm very passionate about, and I think it's been a theme throughout many of the things we've been talking about already this morning, is firefighter safety. That's our #1 priority when we're looking at technologies. The second thing we're looking for is firefighter safety, therefore results in community safety. I want to find ways that we can do our job more efficiently. We can minimise the time that we're required to be at an incident so we can be home with our families. And as introduced, that's a very important thing for me. In the last couple of years, by now having my own young family, that's really motivated me to think about firefighter safety and how we can do our job better, safer and more efficient. Just some other really key things just before we jump into it. The team is made up of a number of technical officers, a number of people from the engineering background, looking at things like next generation fleets, what does our PPC look like in the future, all that kind of stuff. But one of the really key things that I want to call out about the Firefighting Advancement and Research team is the library. So the library, the RFS library at headquarters, forms part of the Firefighting Advancement and Research team. I learnt a few years ago when I was doing a bit of study myself just how much of a hub of knowledge our RFS library is, and Katie in the library. You can go to that library and ask any question about anything emergency management related. Katie will probably pull out a book for you that'll answer all your questions. So I really encourage people to reach out and engage with our library as well, because to me that is the home of where our research lives. So the first thing that we are looking at the moment, and Firefighting Advancement and Research as a team was stood up the way it is now under the recent headquarters realignment. One of the things that we've taken carriage of is the Next Generation Fleet project. And I know a lot of people have probably heard a lot about Next Generation Fleet. I'm here today to cover a couple of very quick topics. I understand just recently there was an RFS Connect video that's gone out with some more information about Next Generation Fleet. So I'd like to talk about some of the streams of work for Next Generation Fleet. One of the key things about Next Generation Fleet is understanding the cab chassis of the vehicles that we'll be driving in the future here in the RFS. That's been driven by the Euro 6 cab chassis selection requirement, and that is a requirement that's coming in the next couple of years, which is really changing the design, or fundamentally, but changing the design of the cab chassis that we're working on at the moment. So that is a big project that's going on right now with the fleet team, understanding and procuring the next generation of our cab chassis themselves moving forward. The research and development of appliances. So by going through the process of identifying the cab chassis, we've now identified this really key opportunity to think about what's the thing that we bolt onto the back of that fire truck. Some of the key things to consider there is what are the future needs of the RFS. We don't just do fires anymore, we do a whole range of incident types. What are the future needs of the RFS, and how can we design our vehicles to be better prepared for that? Another one of the key streams of work to do with Next Generation Fleet is around the ROPS and FOPS testing, so rollover protection and falling object protection, and I'll cover a little bit more information about that very shortly. So some of the key objectives that we have here in the Firefighting Advancement and Research team for Next Generation Fleet. We're working to engage with the market to procure, as I said, that next generation of cab chassis to meet that Euro 6 emission standard, which again is prompting all of these other questions that we can ask about our fleet and have a bit of a rethink. To achieve that, we've had member engagement across a broad range of groups, support brigades, catering brigades, across the area commands. This resulted in identifying roughly 160 different user requirements or different pieces of information or knowledge from our membership to inform Next Gen Fleet and what we're doing. This has then resulted in basically drafting up of 15 different spec sheets that is going to inform what Next Gen Fleet looks like. But the key thing, as I keep saying, we've taken this as an opportunity to rethink what our fire trucks look like in the future. We don't want to just keep rolling out with the same thing, although acknowledging that our current fire trucks are very fit for purpose with what we do now, but we now have this opportunity as a rethink. And I just want to touch on some of the examples of some of the technology that we're considering as part of Next Generation Fleet is on display with the Wesley truck out the back. And I encourage you, please go have a look and discuss it with the team, talk about the technology and understand the technology that we're looking at. Some of the key themes that I work with as part of the Firefighting Advancement and Research team, and very much feeding into the Next Generation Fleet project as well, is how can we make our firefighters safer? How can I make the operations of the RFS safer? How can we be more efficient with our firefighters' time? How can we have more efficient equipment, PPC? And how can it be more fit for purpose for what we're doing today? As I said, another one of the key projects aligned with Next Gen Fleet is understanding the ROPS and FOPS, so rollover protection and falling object protection. A lot of this work has come out of recommendations following the 2019 and 20 fire season, and it has resulted in us engaging with the Monash University Centre for Accident Research to understand through a couple of different phases how we can improve, or how can we understand and improve our rollover and falling object protection. So phase one of that has been an evidence review, understanding the context of our operations, of our fleet, where we drive them, what are the hazards that they face. And we're also doing that baseline testing to understand what our current fleet, how it performs in rollover and falling object protection. And very importantly, there's a couple of images up there. That's some of the work that's been happening in the last 2 weeks. So this is where at the moment we are now at a point where we're crush testing a number of our cab chassis or our cabins to understand the level of protection they currently provide. Because from there, we want to go into understanding, is there something we can be doing better to provide more protection for our firefighters on the fire ground? We have a goal of having something, and I want to be very clear, we don't know what this looks like yet. I hear a lot of rumours about every truck's getting a roll cage or this or that. We have no idea what this looks like yet. This is a true research project that we're partnered with Monash University on. Step one, understand where we currently sit. Step two is, with that understanding, design, develop, work out a solution that can better protect our firefighters, and then look at how we can implement that. But we have no idea what that looks like yet in terms of a physical thing that might be on the fire truck. Okay, so just to be very clear, this is a pure research project from that perspective, and there's going to be a lot more engagement that has to happen before we start implementing any of this stuff. But we are working on it. As you can see there, we've got a number of cabins that have already been crush tested to understand that data. I want to talk about some other innovations. I know Next Gen Fleet is the really big project that everyone loves talking about. It's all over the place. I want to talk about some of the other innovations that we're working on here in the RFS. Again, with that goal of making our firefighters safer, making our time more efficient, making the community safer. To do that, we are partnered with the Office of the Chief Scientist and Engineer on a number of challenges. One of those being the Natural Hazards Technology Pilot, of which the Rural Fire Service is engaged on a number of the projects with this. The Natural Hazards Technology Pilot works across all of the emergency services, so there are flood challenges, there's recovery challenges with the Reconstruction Authority. The Rural Fire Service is the lead on 2 of these challenges. The first one being our command and control interface. So this is very much a back of house, one of our technology solutions that we're looking at. We know that we've got a number of different systems that our incident management teams have to interact with on a daily basis when we're responding to fires. We're looking at ways of maybe how we can bring that together into a more simplified decision-making support tool for our incident management teams to then better assist our firefighters. But one of the ones that I'm really excited about, and one of my passions, is trying to figure out how we can better deal with hazardous trees in the fire ground. And one of the challenges that went out through the Office of the Chief Scientist was, does any company out there have any idea how we can solve our challenge of identifying hazardous trees before we send our firefighters in to go and find them? So excitingly, we've partnered with Ninox Robotics just recently to understand. They've come up with an idea of, can we fly a drone and use LiDAR or a range of other sensors to try and find hazardous trees. Just last week, we finished the work of flying down in the south coast, and we hopefully this week and in the coming weeks will be going through the data to understand if that is a viable technology solution to finding hazardous trees. The next one that we are working on, and we've partnered again with the Office of the Chief Scientist and Engineer and our fellow firefighting authorities and agencies here in New South Wales, is the Natural Hazards Detection System. So this is a very new challenge, something that we've been working through this week. And I think a lot more information is about to be announced through the Office of the Chief Scientist about the successful applicants. But very excitingly, and as Commissioner Rogers alluded to earlier, we are partnering and looking at ways that we can find fires using other methods apart from 000. So are there any technology solutions that can find fires for us? So excitingly with this one, we are looking at ways that we can identify fires through the use of camera technology. Are there space-based detection methods that we can use to find fires? With the clear challenge being fires that we know that burn in remote areas that can burn for a couple of days before anyone knows about them, and then we get a bad weather day, and then that fire takes hold. If we can use other technologies such as satellites, drones, cameras, I'm not saying what a solution might look like, that's what we're trying to work through at the moment, to find those fires, to then be able to dispatch appropriate resources to contain those fires. We all know what the outcome of that could be. Keeping those fires small, preventing fires from getting bigger. Some of the other really exciting work that's happening with the natural hazards detection system is understanding if there's a better way that we can understand environmental and weather data in the field. Instead of relying on our traditional methods, it's a bit of a challenge to rethink that and understand if we can deploy a whole heap of sensors into the environment that'll give us better information about when it might be suitable to do a hazard reduction, or it can give us that really localised weather for our fire behaviour teams to start getting better predictions of those fires. So then, again, there's some of the challenges that we're working through at the moment, and working with a number of private companies here in New South Wales to try and solve some of those challenges. Phase 1 is kicking off as we speak at the moment. That's a bit of a proof of concept that will run for a few months while we partner with these companies to understand their technology and to prove the concept, prove the technology works, before we then start going to phase 2, which is a much more expanded trial. And that's where I'd really love to see a lot of this technology deployed into regional New South Wales to understand how we can find fires and how we can get better data, weather data about where our fires are burning as well. So some really exciting work happening there. And I think in the next couple of weeks, we'll get a whole lot more information out about that, but keep an eye out for that as well. Another one of our key projects that we've been working on over the last couple of years, again, following the 2019-20 fire season and some recommendations that came out of the inquiries, was to understand how the Rural Fire Service can better use technology on the fire ground to make our firefighters safer, to improve our situational awareness, to therefore improve the information and the warnings and the work that we can do with the community to make them safer. So over the last 2 years, we've been partnered with the Australian Centre for Robotics as part of the University of Sydney. This partnership has aimed to explore the possibility of a network-centric firefighting concept. The idea is to, and I'll go through a number of these things at the moment, but the idea is to bring together a number of technologies into one network-centric operation to better improve firefighter safety, situational awareness, so we know where our people are, for example. And it's important to know that the work that I'm about to cover is all experimental work. We've been trialling it, trying to understand the technology. It's not necessarily work that's going to be rolled out in the short term, but it's just experimental and research work that we're doing. So to achieve that, there's 5 sub-projects to this work that we're doing, being the tethered drone. And if anyone's been walking around the expo, you'll see a number of these technologies at the Firefighting Advancement Research stand. But we have the tethered drone, autonomous field patrolling robot, something I'm very excited about, wearable devices, so understanding and testing wearable devices for firefighters, vehicle telemetry, so understanding more about our vehicles rather than just what some of the basic information we get right now being automatic vehicle location, for example, and then understanding how we can bring this together and also integrate our aviation network, so our helicopters into this, to then further to extend that reach to be able to support people like our remote area firefighters as well. So the first one I want to talk about is the autonomous field robot. Has anyone seen this? Can you give a quick show of hands? Anyone who's seen this? Has it been at Region North exercise, state championships? We've tried to get it out a little bit. It's a really cool piece of technology. Some of our goals with this robot is vegetation and fire trail assessments. So an automated, it can drive down a fire trail auto by itself, using a range of sensors that are on the robot, and I've got a video that'll show this very shortly, to do a fire trail assessment. We can use that in planning for hazard reductions to understand what the fire trail is like, but we can also use that operationally, and I think this is where it's really key for us. Using this operationally, if we've got a fire and we're doing an assessment of some fire trails, for example, for a containment line, we can send the robot down. We don't have to send firefighters down. It can do an assessment of that fire trail, the condition of that fire trail. It can inform us what type of vehicle we can send down there. It might be a Category 1 trail on the map, but it says we can only really send Category 9 vehicles down there. And also giving us a vegetation assessment along that trail as well. That can inform incident management teams of, is it suitable to do a backburn from, for example. Vegetation mapping is another thing, so we're looking at how we can use this outside of that operational. How can we use an autonomous robot to go and do vegetation mapping for us and understand the vegetation, the fuel loads, and that sort of information to inform potentially hazard reduction work, or informing the work that we're doing with the bushfire risk management plans. But the key things there are autonomous trail navigation. It does not require somebody to drive it. The idea is that we can send this down without putting our firefighters in harm's way or reducing that exposure to the risk. Some of the other really key things that I'm looking for, again, I refer back to the previous project of the Ninox robotics and hazardous tree identification. Some of the key things that I'm really pushing for and looking for out of technology like this is, can something like this drive down a fire trail and identify hazardous trees for us before we send fire trucks down there? Acknowledging, yes, it's a robot, it won't be able to deal with that hazardous tree for us, but what that allows us to do is know where the hazardous tree is, and we can then send in our specialist crews to deal with that hazard before we then send our firefighters in. Again, firefighter safety, #1 priority for this. And I guess the end advantage of all of this is it actually maps the fire trails for us as well. So we get a whole lot more data and information about our fire trails, the condition, where does it go, and a lot of the other characteristics around the fire trail. The next slide is a video, if it automatically plays for us. So in this video, the robot is autonomously driving. So the driver is there, but as you can see, hands across, there is no driving happening there by that driver. It is using the range of sensors on board to understand the fire trail and where it can go. And then this is some of the data that we're then getting from that robot as well. So as you can imagine, if you're sitting in an incident management team, for example, or if you're a DivCom or something like that, and you wanted to understand a lot more detailed information about a fire trail, potentially to use it as a containment line, potentially to do a backburn from, you can see where some of this information can start feeding that decision making. And again, my passion, I want to find the hazardous trees. The next technology that I'll talk about is the wearable devices. Again, these are on the table down at the Firefighting Advancement and Research stand. I encourage you to go down and have a look, have a chat with the team about the wearable devices. One of the key problems that I would like to see solved with wearable devices, and I'll paint a bit of a scenario. You go to an incident, and if you have AVL, we can see on our CAD map, on our common operating picture, where the fire truck is. But my experience as a firefighter as well is, the fire is generally a few hundred metres away from where that fire truck is. And generally speaking, if there's going to be an issue, that's probably where it's going to happen as well. One of the key things that I want to be able to do with wearable devices is understand where our firefighters are on the ground, not just where your vehicle is. Therefore, if something happens to you, we know how we can get help to you a lot quicker, not just to your truck, but to you. So that's one of my key things, and that's why we have GPS built in. The next thing we've got is impact or fall detection. So if a firefighter falls down on the field, just like a lot of smartwatches these days, will inform you that you've fallen over, and if you don't do something about that, if you don't cancel an alert, it can automatically then feed back into the system and tell us that somebody may need help. Okay? It might tell your crew leader that you've fallen, you may need help. It may then inform other systems down the path. That's things that we're working on. Volatile detection is another key opportunity that we've got here. I think through a lot of the work after the 1920 fire season, respiratory protection and all that sort of stuff, we now have an opportunity to understand a lot more about the environment that our firefighters are working in. And this is not just in the hazardous environments, this is bushfire environments and all the environments, flood work. If you're sweeping out somebody's garage and there's potentially something that someone hasn't picked up or detected, we're looking at how these wearables can inform that sort of scenario. Particulate sensors, very much again the same idea there. And then another key opportunity for us is to understand some really localised weather as well. So we're looking at how we can have temperature and humidity sensors in these wearable devices. That goes to informing the fire predictions and the predictive services team, but it also goes to informing the health and safety of our firefighters, understanding again the environment that people are working in. And that can start to inform things like, do our firefighters need to have a break because they're working in extreme temperatures, for example. We now have an opportunity to be able to capture that data to support our decision making in that. And just...
Sorry, while you're on that subject, there was about 10 years ago a monitor between the front and back seats.
Yes? Yes. Yeah, sure. So the question, just very quickly, was about 10 years ago, and I'm not aware, so I'll work with you on this one. There was discussion around potentially having some kind of monitor, if I'm getting this right, pull me up if I'm not, between the front and back seat of the trucks to be able to control pumps. I'm not aware of any of that work, but what I will say is please have a chat with the fleet production, the fleet team here, the next gen fleet team, because if that's an idea and if that's something that we can consider, why wouldn't we? As I said, we're at this opportunity. We're allowed to rethink the whole thing. So I've read the documents, so they're very broad of what we're allowed to do, so let's go and rethink the whole thing. If that's not an idea that's been considered, please reach out to the team and talk about it. Thank you. The next one I want to talk about is our tethered drone. So the tethered drone, again, this is at our stand. I'm shameless plugs for the stand, so please go and speak to the team. But the tethered drone is a concept that we're looking at to form a bit of an eye in the sky for our firefighters, and there's some key advantages to having something like this. So again, tethered drone, situational awareness from above. This tethered drone sits about 30 or so metres. We have no idea about what the height may be, but we're looking around that 30 metre mark. It gives a live stream of RGB and thermal video, so a range of cameras on it, and there's a video shortly which will show a number of these things. It also acts as a repeater for our, we call them BMUs, but they're basically the wearables. So it acts as a repeater, it gives us a further range. We don't rely on any of the Bluetooth networks or anything like that. It's its own network. But the key advantage to being tethered is continuous flying. The drone itself is powered through the tether, through the vehicle. For this experimental work that we're doing at the moment, it's powered through a generator, but it'll be powered through the vehicle. The idea is power it through the vehicle for continuous flying. You don't need to land it, change batteries or anything like that. The idea of the concepts is basically you rock up to an incident, you push a button, tethered drone goes up, does its thing. When you're done, you push a button, tethered drone comes down. You don't have to think about it more than that. That's some of the work that we're doing with the university to understand how we can make that a reality. Some of the key things about the tethered drone though, and I wasn't fully sold on the tethered drone until I saw it in action, and now I want them everywhere because of the information, the situational awareness that it gives our crew leaders, our divisional commanders, our incident controllers, and us in state operations about what's happening there. So some of the key advantages that I see there is it places less load on our crews to give sit reps of things that you might not be able to see as well. We have a tethered drone sitting 30 metres above that's got a different view than as a crew leader you do standing on the ground trying to look through trees at something. So giving us that much quicker situational awareness can then inform things such as community information and warnings about that fire. It allows our incident management structure to be able to monitor what's happening on the fire ground. Do our firefighters need further assistance? Has the fire spotted in another direction? All of that sort of information becomes available to us when we have an eye in the sky. The next slide is a video of fireground monitoring. So just very quickly, this was a scenario that we ran in Waterfall in South Sydney. So it's a smoke machine itself, but using the tethered drone, the camera, to be able to find that fire. That fire was, or the scenario was about 400 or 500 metres away from the truck, and that was the image that we got. The next one that we had was, we simulated throughout the whole network-centric firefighting, a wearable device. We simulated a firefighter falling over. The system was configured that as soon as a duress alarm came through from one of the wearable devices, that the camera would snap to that location. Again, about that situational awareness and firefighter safety, we could get a much more rapid appreciation of what was happening on the ground there. The next one I want to talk about is vehicle telemetry. So vehicle telemetry is kind of seen as the brain of the network. It's kind of the hub of everything that's going on with this network-centric firefighting system, I guess. So it acts as a data fusion unit, so it brings in the information that's coming through from the tethered drone, from the robot, from the wearables of our firefighters, brings that information through, and we're forming a bit of a common operating picture. We're still working on where this information could live, who has access, all of that kind of stuff. But the vehicle itself is the hub for this information. But some of the other things we've taken a bit of an opportunity for when we're looking at a fire truck is, can we have a tilt and roll sensor in the vehicle as well? So we've got vehicles that are driving on fire trails all day, every day. Can we get data and information about our fire trail network through a number of sensors on the truck without our firefighters even thinking about it? We are getting a better understanding of the fire trail conditions. But also that then gives us an opportunity for potentially some automated duress alarms. If the system detects that a truck has rolled over or something has happened to that truck, we can automate an alert that comes out. We don't rely on the crew trying to get a warning or alert out to us. We can look at how we can automate some of this stuff. Again, firefighter safety, trying to make your lives safer and easier. Another one that we've been thinking about is something as simple as having a number of thermal sensors around the vehicle, just thermometers essentially, that give us some information about, if you've ever been to a fire and you've gone away from the fire truck to go and deal with the fire and there's a spot fire that's approaching your vehicle, we've just thought of something as simple as maybe we put a number of sensors around the vehicle that can sense a fire is approaching the vehicle, that will warn you to say that if it's happening on the other side of the truck, for example. And some other data that we're looking at is, can we get a fuel level sensor? Can we get a water level sensor? Can we get some of this information into our systems to better inform our incident management teams about what support they might need to provide to the fire ground? If everyone's running low on water, maybe that triggers something in a system to say you need to send bulk water support to them, for example. So we're looking at ways of using this technology to better inform the decision making through our incident management teams. And the final piece to these 5 projects is helicopter integration. So it's essentially taking a number of the sensors that I've already spoken about and figuring out a way that we can bolt this onto our helicopters to then be able to support our remote area firefighters, knowing that they are the ones that go into a location, they don't have the support of a vehicle, they might not have the support of a lot of the technology a vehicle can then bring. So we're understanding how we can bring that technology and this support through the use of our aviation network. If we've got a helicopter that's dropping our firefighters in, why can't we have a system that communicates with our firefighters without having to use radios, that gives us information about where our firefighters are? What's the weather where our firefighters are? What are some of the metrics around what our firefighters are doing? Again, do they need more assistance? How can we better support our firefighters on the fire ground? Some interesting facts with this one. The university have been using a number of different frequencies to try and get the best range out of it. We did a test about 8 weeks ago in Penrith where we were seeing about 3 kilometre radius independent of any other systems. We were seeing about a 3 kilometre range for our firefighters and being able to communicate with the helicopter. So that's pretty impressive. I know that our firefighters, our remote area firefighters, can work a lot further away, but we're at least starting somewhere with that. So very quickly, I just want to walk you through a bit of a concept of operation about bringing all of this technology together. I know I've just spoken about 5 different technologies individually, but what does it actually look like if we bring all of this together, and how can we support firefighters on the fire ground? So in this scenario that you're seeing here, a firefighter has fallen over or a firefighter is in distress. So the wearable unit that firefighter was wearing has detected that. No requirement for that firefighter to try and raise the alarm. The wearable unit has detected that. That wearable unit also gives us the location of that firefighter through that long distance communication protocol that's in place. Through the tethered drone, as I said before, the tethered drone will then snap to that location and give us a visual of what's happening there as well. Again, the firefighter hasn't had to do a single thing with this. We've all of a sudden now got eyes on what is happening there. We know where it is happening, independent of where the truck is. We know where the person is that needs help. If the robot is deployed and can get to that firefighter as well, then the robot can go and also provide some kind of assistance. We're still yet to figure out what assistance a robot can do there, but even if that is giving us information, intel about how we can get further assistance in there, is it the map of the fire trail that the robot used to get to that person that we can then use to inform other agencies to help us? All of this information is then fed through that vehicle telemetry or the hub that's in the vehicle, process that, and then fed into other RFS systems. Now, we don't know what those other RFS systems are. It may be Athena, it may be Icon. We don't know yet. This is all the joys of research projects, and we get to figure all of this out as we go. But then that allows our incident management teams, our communication staff, whoever it may be, to arrange and get that assistance to our firefighters without the firefighter having to really do anything. So the next part of that is also if that occurred for our remote area firefighters, obviously you can remove the tethered drone and the robot if it's not deployed, but we get that information through the helicopter integration piece that we've got as well. So some of that key, making sure that all of our firefighters essentially have equal access to this kind of technology. So throughout this project, there's been a number of engagement pieces that we've gone through, the Northern Region exercise, state championships, Southern Highlands field testing on a weekly basis. We've done a number of tests down at the Royal National Park, and then just recently working with Cumberland Raft team to do some of that helicopter testing as well. I absolutely acknowledge that this technology requires a lot more consultation and engagement with our membership. And that is one of my goals moving forward, and I'm about to talk about how to get involved. But I want to get this technology out to our membership. I want to be able to have the conversation about why won't it work for you? Why will it work for you? And what other issues that you can see that we're not potentially looking at. So as I said, with that project, it was a 2-year project that we've been working with the University of Sydney on. That is kind of coming to an end right now, but it's got a number of people in the RFS, including the executive, and I thank them for their support in this. It's got a number of people excited about the potential for a lot of this technology. So moving forward, we're just going through right now a bit of a technology roadmap with the University of Sydney about understanding how we can integrate some of this technology into the RFS. But we're also very busily looking at our options, potentially funding options, all that kind of stuff, to be able to continue with this research, because I think this is really important research, and I think this is really important work that we're doing for firefighters. Which brings me to my last point. of how to get involved with the work that the team is doing, because I absolutely acknowledge that innovation is not a headquarters-centric thing. I look out again at the vehicles that we've had out the front, our heritage vehicles, the PPE and the PPC that we've got, the techniques, all of that kind of thing that we've been working on, that has evolved over 120 years at a local level. So please, I want to engage with our membership as much as possible. In doing that, I ask, please, for the membership to challenge our assumptions in what we're doing. Don't think that everything I've just presented then is right. I want you to challenge our assumptions and tell us your local context. Tell us why this won't work for you. So to do that, please go and have a chat with the team at the Firefighting Advancement and Research stand. And hopefully in the future, I aim to have a lot more information on our One RFS page. I really would like to see eventually some kind of a hub where we can generate ideas from the membership about what's happening locally. I'm working on it. I don't have a timeline. I've got too many good ideas in my head, and the team have just got so many good ideas we're trying to work on, but that is something I'm really passionate about, is getting the ideas from our membership, because I know headquarters can come up with all these really good ideas, but I'm really keen to understand the local context and what's happening local and how can we solve some of those challenges. So in closing, I just want to tie this back to the theme of the conference and some things that really resonate with me. Engage, advocate and support. So please, I ask you to engage with us, engage with the team. Again, tell us what are the challenges that you're seeing. And in doing that, we will engage with you and we'll tell you some of the ideas that are being brought to us, and we'll be able to hopefully share across our membership. I want you to advocate, and the key thing for this, the thing I've been thinking about advocating, is I want you to advocate for your local context. I know that one size does not fit all for everything we do in the RFS. I know that we can't make a thing that'll fit every single person either, so please work with us on that. But I want you to advocate for your local context. What is happening in your local area? What are the local challenges? And then the last part, support. So I commit that the team will support our membership in delivering this technology, but I also ask that our membership has a bit of an open mind with some of the things we're looking at, and support the team in thinking about some of this technology and how it can make our lives safer and more efficient. And I think that's meant to say thank you. And I don't know if we have any time for any questions. Yeah, perfect. I'm happy to.
We can certainly take one or two quick questions. While you're thinking of questions, I'm going to present you with a gift on behalf of the RFSA. Please thank Simon and Simon's team. I think it's some nappies. Yes, we have got a question. Actually, hang on one sec. We will need the microphone. Reason is, even though we can probably hear some people here, it's difficult for people on the other side to hear. But just as importantly, perhaps more importantly, we've got the people online who will not be able to hear a thing, and they'll have to guess what the question is. So if you can wait till the microphone finds its way to you. Thanks again.
Just with the drone technology, is there an issue with seeking permission from landholders using the drones, not necessarily when there's an act of fire happening, but pre-fire planning and so on?
Yeah, definitely. So these have been, some of these questions have been a little bit beyond the scope of the particular research that we're working on. And for some of these questions, I also encourage you to reach out to the operational field support team. They're opposite us. We've got a bigger drone, by the way, but anyway. I encourage you to reach out to them because they're really looking at that operational side of things right now. The work that we're doing is understanding how this technology could be implemented into the future. But we know that, I wouldn't say there's been significant hurdles, but we know that we've got to work through all the CASA approvals. We know that we need to figure out how we can integrate tethered drones with our aviation fleet, because we can't have tethered drones up there that ground our aviation fleet, because we all know the support that a couple of thousand litres being dropped on the fire ground actually gives us as well. So I'd rather a couple of thousand litres of water than a picture of it, right? So we know that this is some of the stuff that we need to work through over the coming years. It's just the ideas that are bubbling away in our mind at the moment, and they gave us some money to go and test it, so that's what we did. But please reach out to the operational field support team. They are probably going to be able to answer your question much better than something I can make up. Thank you.
Thank you. We'll take the question there, and then we'll take this question down the front.
G'day, sorry about that. I was just watching, very interesting. Has there been any thought into like a mobile automatic drone, aerial drone? So in a high-risk area, we get the call-out link for active, but if there's an aerial drone, it can go off and all of a sudden we get, yes, there's a page and it's 10 minutes ahead of our trucks. Crew leaders could see, oh, hang on, that's not on that road there, that's over there. And, oh, my goodness, get back to fire comms, we need more vehicles because we can already see what's happening. You know, say like when Gospers kicked off in the big fires, if they had a drone in the particular brigades where we know we're going to have problems, it would have just automatically gone and been ahead of the game. Has that been considered? That's all I'm asking.
Yeah, I can certainly answer that question. So part of the natural hazards detection system challenge to the Office of the Chief Scientist, one of the challenges with that is find the fire, but also monitoring. The way I see this in my mind, and again, this is very, very early days, is we know that we've got elevated fire danger in an area, so total fire bans, for example. We're working with a couple of companies that have got similar technology. We're going to understand how can we, as a trial, deploy some of that technology onto the fire ground that will give us that instant situational awareness if there is an incident. Now, the other thing that I'll challenge that with is saying, it's not just drones that we're looking at with that. As the Commissioner mentioned earlier, we're very excitedly watching on with what's happening with the X-Prize competition and the use of satellites to do that sort of a thing. We're looking at, and some of the goals of that competition are, how can we find fires anywhere on Earth within 10 minutes? But then how can we get real-time information about what that fire is doing? And I see that happening before we even get brigades on the ground, informing our decisions around, is it one truck or 5 trucks that we need to send? So drones, satellites, it's all stuff that's bubbling away, and I think in the next 5 years is really exciting to see what that technology is going to bring. Thank you.
Thanks for that question. We'll do one more, which was just down here. And then are you going to be around for a little bit if anybody's got questions? Yeah. So feel free to ask Simon during morning tea, afternoon tea. Thanks.
Yeah, g'day. I was just, that bit you did, I think, was on vehicle telemetry about heat sensors on the trucks.
Yes.
And radiant heat.
Yes.
I cannot tell you how many mirrors and panels we've melted on our truck over the years. And I just wonder, have you set a standard for where they actually go off? Because I think every year we end up replacing stuff that is melted. Sometimes by accident and sometimes deliberately, because we're using the truck as a barrier to get out of the danger zone.
Been in that exact scenario. No, we don't have a threshold of 100 degrees or whatever that might be. The way that I see this sort of evolving is the first alert is just to the crew inside the vehicle through potentially your MDT or something to say, hey, there's something hot next to your truck. The scenario in my mind is, you know, you're at an incident, there's a spot fire that's no one's seen that's approaching your truck. Alerts the crew, we'll go and move the truck, put the fire out, done. But a very interesting point that you have there, and I encourage you, and I encourage anyone, if you have any further questions, the team is down the back, Firefighting Advancement and Research. The library is right next door to that as well, the hub of knowledge and research in the RFS. Please go and engage with the teams. Talk about these use cases. This is where I want you to advocate for your local context and what's happening in your local area, because that may be something that we haven't thought of, and we're about to go and launch some technology. So please come and chat with us, come and challenge our assumptions in that space. Okay.
We are going to end it there. Please join with me and thanks Simon. Thank you very much, Simon.